The last Saturday session, Saturday we have taken a seminar, that means some long introduction to Azure Data Engineer products. The related link, the recorded link I am copying into your chart. Please collect that. So when you click on that link, there is a passcode. If you enter that passcode, you can play that. So please confirm me whether it is working or working fine or not. Anyone, please check and confirm. Below is the passcode. For classroom team, after completion of the class, I will give you that link. Anyone, please confirm me in chat, sir. So waiting for your confirmation.
Yeah, it's working.
I'm not able to hear you. So that's why please confirm me in the chat. Yes, sir. Okay, it's working. Okay, so let's come to the actual part of this one. So before going for that, to the next topic, a quick review of the last session. Especially in last session, we have discussed about Azure Data Engineer products. Can you please help me? What are those products? At least classroom people, because online people voice today, I'm not able to hear. So what is OLTP database? Azure SQL. And we have a warehouse environment, data warehouse, that is Azure Synapse. The old name for this one is Azure Data Warehouse. This is old name. Latest name is Azure Synapse. The service is called, to perform the analytics, Azure Synapse Analytics. So this Azure Synapse Analytics has two things: Azure Synapse database, at the same time, analytics service. Okay. Even you can play with the statistical analysis kind of functions also you can apply. Okay. And problem with Azure Synapse is it can store and handle. That means it can store and process only structured data. But lot much of data is unstructured and very little structured or semi-structured. Unstructured examples, a raw text, images, audios, videos, it can be of anything. For all these things, you have one more thing. You have different storage types, but mainly used storage type is Azure Data Lake. That too, in the Azure Data Lake, different flavors are there. Azure Data Lake Gen 1 and Gen 2. Now Gen 1 is going to be deprecated. Already Microsoft is announced. Microsoft announced that by 2024, Gen 1 completely removed. So at the time, but for a lot of clients, already most of data is in Gen 1. The migration is required. Now migrations are happening. Gen 1 to Gen 2 migration. So Gen 1 storage connections creation is different. Gen 2 storage connections creating is different in ADF. So in the migrations project, that will help you. Okay, even though not needed, but old clients, their existing data is already in Gen 1. Now they are migrating. So you need of that knowledge also. But for the free subscriptions, or trial subscriptions of the Azure, this Gen 1 service is not available. If you are using paid service, the Gen 1 is available. That is for all old customers that is available, for new customers that is not available. Okay. But I have old account, some old account ID is there. I will activate that. I will demonstrate you how to migrate Gen 1 to Gen 2. Okay. So latest, remember, just latest one is Gen 2. But what is the connection between these two things? How you can import? If you talk about Azure SQL, that is OLTP. And Azure Synapse and Azure Data Lakes are acting as targets within our Azure platform. Sir, please come. Come front side, please. Shankar, remove that. Just wait, sir. Azure SQL is OLTP. Synapse and data lakes are targets. That means as target warehouse systems. So how you can connect with the source systems and how you can dump the data into the target systems by using the product called ADF, Azure Data Factory. So more technicals from tomorrow onwards, we'll start up with only ADF related concepts. Then we will discuss. Already in the last session, we have taken overview of each and every product. And there are some big volumes of data. If you perform transformations by using ADF, the process will be on big volumes of data, on multi terabytes of data, the process will become slow. It may take hours or days times also in some times. At the time, to make that data process, to reduce the processing time, you have another separate weapon, which is Azure Databricks. What is Azure Databricks simply? Is a Spark cluster. Okay, so you can say Spark environment. So Spark is an execution engine which can process data very faster. Databricks is a provisioning cluster for the Spark. Spark is execution engine. For that, a cluster is required. A cluster means a group of systems are acting as a network of group of systems are acting as a server. The Databricks organization is creating clusters, provisioning clusters for you. On top of the clusters, the Spark is the execution engine. Same Spark execution engine with the Databricks cluster in Azure, that is called Azure Databricks. Understood? So, but not in all the cases, you don't use Azure Databricks. What is a special use case? Data is used, then only use the Databricks. That too, if time processing speed is demanded for you. Data volume big, even though if the process takes 3 days or 4 days time, that is okay for you, then no need to go for this one. But always speeder, but why? Most of your process will be done with ADF, but some special process only they are doing with the Databricks. There is a budget. If for a small data also, if you start using the Databricks unnecessarily, the bill will be high for the client. So finally, we need to take care of cost optimizations also. But sometimes even the cost is high, no compromise. Because data processed results are emergent. Emergencies matters. At the time, you don't care about the cost. But sometimes cost matters. On that way, some processes you will be running with ADF, some processes you will be running with the Databricks. Okay, of course, that is not into your decision. Your architect will decide what kind of processes should run with ADF, what kind of processes should run with the Databricks. But today you are junior, tomorrow you might be senior. At the time you have this, you should have this idea. Okay, and also one more thing, you have a NoSQL database. That is Azure, Cosmos, and DB. In the case of NoSQL, what is the importance of NoSQL database? Already I explained in the last session. What is the basic advantage? Not metadata, structure. That means schema. Record to record, different structures will be maintained. In case of RDBMS table, for every record, the schema is same. That means structure is same. But in NoSQL, record to record different schemas can be maintained. So, but in NoSQL, you have different types of NoSQLs are there, like a key value store, document store, columnar store, graph store. In this way, different data types of things are there. This Cosmos DB comes under document store. Sorry, spell mistake. Document store. MongoDB is popular example for this. MongoDB is on-premise database. And second thing, similar to MongoDB, next AWS, Amazon has launched one more document database. That is a DynamoDB. DynamoDB. Similar to DynamoDB, in case of Azure, that is Azure Cosmos DB. But remember, NoSQL bases are used as OLTP systems, not as data warehouse systems. I repeat that point. NoSQL DBs are used as OLTP systems. OLTP means, online transaction processing systems. Okay, and for end user transactions, not for the batch processing or not for the analytics. Again, I want to perform analytics means, suppose your client data is in Azure Cosmos DB. His requirement is not satisfied by the RDBMS. He has a different schema of the records. That's why I think that our client is using Azure Cosmos DB. At that time, using ADF, you should know how to connect with NoSQL. Understand? Of course, you are a ADF developer, but still you should know how to interact with other data products. So how to create a linked connection, that means linked service, and how to create a data set for Cosmos DB collection. And then how to fetch it and how to dump it to my data lake or Synapse. So all these things you should know. In this way, like once you understand, suppose once you know how to connect with one single source, by doing little modification on the same way, you can connect with other sources. The procedure is same. Got it? So Azure Cosmos DB is also one of the important product for you. And seventh product we have Azure Streaming. What is the purpose of Azure Streaming? That means live capturing means streaming data capture. Not only capturing the streaming data and perform micro batches. Micro batches, what is the difference between batch and micro batch? Generally, if it is a batch, the interval of the batch will be very high. Organizations will be running daily night sales reports. Suppose tonight they run sales report, means again tomorrow night they will run it. There is at least some 24 hours gap is there. Or some organization hour to hour they run batch process, because they are interested about for every 1 hour how much sales are generated. Okay, but online e-commerce kind of applications, social media kind of applications, they are interested not in the hours, they are interested in not in even minutes, they are interested in seconds. For every 10 seconds, which product is getting high visits. So such kind of analysis they require. If the batch interval requirement is that much teeny, that much small, if you are working as a traditional ETL developer, extracting data and then running your jobs in our warehouse system, that won't work out. As streams are producing, immediately the stream should be captured. And there you will set one time interval, maybe 10 seconds or maybe 20 seconds. For every 20 seconds, automatically your analytics jobs will be processing. That means the final estimation expected thing here from this product is with how much speed the streams data is produced. On the same speed that should be captured, and for every given interval of time, for every 10 seconds, the data should be processed. Okay, so that is what, and let me complete this statement. Streaming data capture and perform micro batch analytics. Okay. Here one thing, sir, already similar products, similar to the Azure streaming, already in the Spark, there is another product that is Spark streaming. Okay. So similar to Spark streaming. Got it. And one more important product, of course, this is generally used by the admins, that is Azure Key Vault. This is to store and access policy IDs, secret keys, and remaining keys like public keys and private keys, user IDs and passwords, all these things that you can manage into the Key Vault. See, sir, all these products are in Azure, but for every, suppose I create an account for Azure SQL, I create an account for Azure Synapse. The keys for Azure SQL is different, the keys for Azure Synapse is different. That too, within the Azure SQL multi-databases I will be running. Again, for each database, the keys are different. Got it. So within a single user, within a single application, he is going to use hundreds of keys. Generally, after completion of the session, I used to forget my Zoom user ID and password. If such kind of accounts are 100 for me, definitely I will forget. So without worrying about all these things, simply this application will be managing all these things. Okay, later once we step into the activities, we will be involving into the practical role of all these things. So these are the 8 mostly used products in the Azure data engineering. Okay, this is what the major agenda of last Saturday class. Okay, on Saturday, but we elaborated the discussion. That's it. Already I shared you that recording of Saturday session in the chat. Okay, so for classroom team, after completion of this session, I will give you. And one more thing, sir, here. Before step into the actual ADF, in the industry, you are going to be designated as data engineer. That might be Azure data engineer or on-premise data engineer or AWS data engineer. Or even Google also started a data engineer products. Their products also amazing. That is Google data engineer products. Okay. So what are the data engineer responsibilities and the required skills for him? So these things we will understand today. Then you will get clarity over your role. Anyone, please, unfortunately today, sir, like I try to speak from, not from the earphone, directly from the open speaker of the laptop. So please wait so that I can hear online team voice. Hello. Sir, online team, are you getting my voice now? I'm
Yes,
directly
sir.
speaking with laptop.
Yes.
Earphone.
Yes, it's audible.
Still same problem. Okay. Okay. By tomorrow, I will rectify this problem, sir. Please don't mind.
Okay.
Okay. At least the classroom team. You tell me. Mr. Shankar, already you are a data engineer. You tell me. Data engineer generally, the roles and responsibilities. And finally, you can understand, once you know these roles and responsibilities and required skills with which departments you are going to work, then you will be very clear what is the difference between traditional ETL developer and your cloud data engineer or ADF data engineer, whatever it may be. So mainly one things are here, different challenges. So here I'm including the point challenges also. Okay, some 4 or 5 things I will give you. Number one, you should be capable of handling big data, sir. Here, big data means big volumes of data. So generally, if I give multi-terabytes or petabytes in regular databases, you cannot store it. So Shankar, please stop writing and attend this. I will give you recording, don't worry. But there are some specific topics where I need to dictate some notes at the time I give you. So here everything I am writing on the text notepad. I will give you this recording. So first of all, you should be capable of handling big volumes of data. Handling means here not only storing. You should be able to store, you should be able to process it. For example, your database, suppose you take Oracle. In Oracle, you have one table. Forcefully, you can keep 1 terabyte of data or 10 terabyte of data into this. Forcefully, you can inject 10 terabyte of data. But when you run a query on 10 terabyte of data, database server will be hanged. Already I told you, the OLTP systems are weaker capacity, are having weaker capacity. That's why they are maintaining only recent data always. Okay. So, but today for the organization, today data is terabytes. Already some of the organizations have reached petabytes, zettabytes also. If that much of volume is coming, where to store, that is a important point. Challenge number one. And how to process it, challenge number two. How to process it with optimized cost, that is another challenge. Got it. So that is what here handling means storage and process. Process big volumes of data. This is one thing. And second required challenge here, capable of processing any variety of data. Any variety of the data. Okay, capable of processing any variety of data. Please tell me what are the different varieties. Structured, unstructured, and semi-structured. Whatever the data variety may be, you should be able to process it. Got it. See a small example. If it is structured, what is the data? CSV or tables, such kind of things. I want to process them. I can use simply SQL. I can use simply SQL. Got it, to process this data. If it is unstructured, then problem starts. You have to use NLP with, you can store unstructured data in data lake, okay. But by using select queries, how you will process? Understand? By using select queries, you cannot process them. So to process with, there are special techniques here, NLP with ML models. ML means here, machine learning models. Of course, these machine learning models will be built by the data scientist, but the built model execution should be done by data engineer. For example, just by seeing your image, I collected all my students' images, suppose 1,000 images. End of the day, I need a report, how many males attended, how many females attended the session. Think that input is image. Now here, what are the challenges? Here, of course, if it is image, there is no role of NLP. If it is raw text, there is a role of NLP. If it is, so my question is, my input is 1,000 images. Image is structured data or unstructured data? Purely unstructured.
Unstructured.
So where is the storage point in our Azure? Data lake or Synapse? Data lake. Got it? In data lake, I have 1,000 images, but I need one model which can recognize gender of the image by seeing the face of the image. Of course, data scientist team, that means machine learning engineering team, will build a model for that. Understood? That model execution and processing of that analytics is done by a data engineer. Understood? So you need not to build a model in the machine learning. Scientist will build it. You will execute that model. Understand? So you should know such kind of technique. Suppose if the input is not image, if the input is a raw text data. On Saturday session, I told you example of customer reviews. Different customers will comment in different styles. The input is a raw text. But raw text cannot be understood by your SQL statements. At that time, again, machine learning engineers, by using NLP, they built a model to understand the classification of the text. Whether first review is positive, second review is negative. Okay, on such way, the machine learning engineers will build a model. You will have to process that model. Understood? So what are the tech in this way? Here, data engineer means always single data engineer cannot do all the things. Single data scientist cannot do all the things. Scientist needs your help. You need the scientist help. You both mutually interacting each other, especially in the data engineering department. Because nowadays, most of data is unstructured. But in the unstructured data, previously in olden days, they used to neglect unstructured data. Only they are maintaining a dump of unstructured, but they don't use it. But within that unstructured, a lot of useful information is available. Understood? So that's why this is another important challenge, unstructured with ML models. But for the data migration projects, it is not required. Think that already your client has migrated his on-premise to cloud completely. Then next work will be like this. At that moment, your client needs all this. And semi-structured already somewhat SQL can process it. Got it? If it is semi-structured, or else like you can just straight away you can use even ADF can process semi-structured. But volume is bigger, I can use Databricks for the semi-structured data processing. What are the examples for semi-structured? JSON, XML, like this. Still, I know better about these two things. Still, other formats also there. Got it. So these are the major challenges. The first one is important. First, how to store big volumes and how to process big volume. That too with good speed, with less cost. I tell you the examples of less cost later, where you can apply the less cost. And capable of processing different formats of data. So previous my statement was different variety of data. Now I am saying that different formats of data. Okay. What are the examples of different formats of the data? No, that is plain text. Already generally plain text, there is no question of, there is no challenge if it is. There are sequence files. So what are these files in later coming discussions you will be seeing, sir? Sequence files. And there are ROC files. And nowadays there are Parquet files. Most of our data is coming into nowadays, most of our data is coming into Parquet formats. Internally, that is maintaining data in columnar storage format of data. Okay, that too now next to the Parquet, already advanced formats came into the picture, hybrid columnar formats. Parquet is just a columnar format. Next level files, HC files, hybrid columnar formats. Even data scientists are using HD5 format, HD7 format, such kind of formats they will be using. Got it. What is the basic advantage? I am not going into, so for now, I am not going into internals. Majority of your work will be with the Parquet files, sir, being a data engineer, remember. Whether it is on-premise data engineer or cloud data engineer, you will be working with the Parquet files mostly. Okay, one scenario I will tell you. What is the basic advantage of Parquet if I use Parquet files? 75% of data compression. In the Parquet, with the different conversion types are there. Among them, one of the conversion type causes 75% data conversion. And second advantage with this Parquet, faster access of data. Generally, if I compress a file, processing is very slower. So generally, how you write your records in our file or in our database, row wise, right? First record, first row, second record, second row, row wise. If I zip it, the plain rows will be compressed in row style only. In row style only, those will become compressed. But at the time of reading, compressed should be decompressed and then the processing should be done. Whenever you are trying to access a compressed file, accessing will be slower. But in case of Parquet, access is super faster because internal storage style is not row wise, is a column wise. So how exactly the columnar stores will work? Okay, once we step into that NoSQL part, which is Cosmos DB, I will explain how columnar storages will work, how document storages will work, what is the internal architecture and benefits you can see. Understand the point, sir? So faster access because of what? Columnar storage format. This kind of advantage I am getting. Now, because of this advantage, now come to the scenario. The client scenario is like this. In on-premise, 10 TB file is there. In on-premise, not in the cloud. Okay. Of course, meaningful data, which is CSV file. CSV file means that is structured. Now the task is like this. The task. Keep file in data lake. Okay. Process and store transformed data. Synapse. Even Synapse is also bad idea because data volume is 10 terabyte. 10 terabyte is a big volume. Even Synapse, keeping that 10 terabyte in Synapse also, that is bad idea. That's why want to keep into data lake again. Now I want to dump my raw file into data lake. Finally process the results also into data lake. Okay. Between them, ADF is my weapon. Now the processing time, storage cost, let's say $100. Processing execution cost, let's say $100. Totally, for this process, $200 bill is applied to the client. Again, same process tomorrow is required. Tomorrow onwards, whatever the data lake file is there, by taking the data from this file, They want to perform different analytics. Got it. Now he wants some cost minimization. Now, in what way, what is our thinking style to minimize this cost? 10 TB. If I convert into Parquet, what is the conversion? 75% conversion I am getting. Now my 10 TB is converted into what? 2.5, right? 75 savage. Suppose think that Azure is charging $10 for the 1 TB. For 10 TB, $100 is the cost. Now, if I convert that at the time of loading into data lake only, if my ADF could able to convert that into Parquet, what is my storage cost then? 2.5, only $25. Got it? To process 10 terabyte of data, I got 100 minutes time. But to process 2.5 TB data, I get only 25 minutes time, right? That to internal format is a columnar format. This 25 minutes will become 10 minutes, right? Because of 10 minutes processing, my bill will be not $100. Processing bill is not $100, only $10, right? On that way, you can make $200 cost into $20 cost. This is one of the technique. Like this, so many techniques are there. Okay. So being a senior data engineer, you should concentrate on cost optimizations also. In how many ways that you can process this data, which is the better optimized way. But I repeat the word, in some situations, cost not matters. Even the cost is high, we go in a speeder way because speed is demanded in some situations. All of you understood about this. So this is another important challenge for you. So please summarize this thing. You are a data engineer, that to cloud data engineer. You are not going to do all these things into the on-premise. Into the cloud you are going to do. Maybe Azure, tomorrow maybe AWS, like that. So should be able to capable of storage of big volumes of data and also able to process them. Some processes I do with ADF, some processes I do with Databricks. Got it. And second thing, different varieties of data processing, storage and processing. And you will be getting different formats of files. Parquet file, processing style is different. ROC file, processing style is different. Of course, ROC sequence files, all these things almost outdated. Now, especially in Azure and in on-premise or in other clouds, most of your big volumes of files generally will be converted into Parquets. But nowadays, other formats came into the picture, that is hybrid columnar formats. So in the case of Parquet files, only column partitioning will be applied, sir. In the case of hybrid columnar, row partitioning, column partitioning, again, row column partitioning, hash mapping. Such kind of special techniques will be applied. More faster than the columnar formats. That means more faster than the Parquet files. Maybe tomorrow you might have to work with that. The future data engineer will be working with that. Got it. Already Snowflake kind of modern data warehouses have implemented hybrid columnar formats of storages internally. Got it. Definitely Azure has to adopt it. AWS has to adopt it because of its advantages and its local competition. Got it. Yeah. So these are the third important things, and fourth one. Same data converted into columnar format. Same data converted into columnar format. For that, you have to understand columnar architecture. Internally, some special architecture will be there. Okay, it's not right time to explain it. Once if I step into the formats, different formats of files, I will explain about each and every file format. What are the plus and minus points under each format? Okay, till then just have idea the columnar formats are very fast to access when compared with row formats. That with the parquet compression, I'm getting two advantages. What are those two advantages? With 75% of data compression, so that storage cost will be reduced for me. That is super faster. So processing cost will also be reduced. Got it? Okay. Next number fourth product here. That's not it. The fourth important skill should be constructing data pipelines on streaming data. And perform tiny micro batches. Tiny micro batches. Already I explained about it. Because of IoT involvement, because of logs involvement. Previously, logs were used only for understanding running system problems. But nowadays, these logs are being used for user behavior. They are tracking user behavior. They are understanding user psychology. On which product he is interested, on which product he is not interested. They are able to understand because of these web logs. Definitely for the big application, big online application, in a second, thousands of weblog records will be produced. You should be able to capture them and perform the micro batches immediately. On such way, you have to construct your streaming data pipelines. Got it? So all these are the different challenges when you compare with other what you call traditional ETL developer. And one more thing, not only with the streams, not only with the traditional RDBMS, any kind of data connection with what you call any kind of means any kind of databases, what I wanted to say, any kind of databases. Generally, you are working with RDBMS or else normal files. Of course, file is not a database. Okay. Now, NoSQL databases are there. That to one single NoSQL cannot solve all the problems. For different purposes, different type of NoSQL organizations are using. Got it. For example, a Facebook sign up stored in key value store. Immediately user ID password tracked into. So first, when I sign up into Facebook, my sign up will be stored into document, maybe MongoDB. Immediately my user ID password will be tracked to key value. If I do some search in the Facebook, the search results will be coming from columnar storage databases. If I add a friend, a connection is created. Again, that friend is adding another friend. In this way, one friend is a direct connection to me, another friend is indirect connection to me. These connections are called graphs. The two graphs are two types, one-way graph, two-way graph. A small example for one-way graph or two-way graph means, just I'm giving overview of all these things because all this knowledge is important. For example, I am your teacher, sir. I am your teacher. You are my student. From I to you, what is the relationship? I to you. Arey man, for me, who are you? Student. That is the relationship. For you, who am I? Not student, right? Huh? That means a teacher. For me, you are student. For you, I am teacher. Now, it's a one way or two way? No, man, one way.
One way, and
Two-way
it's
means-
master-child relation.
Okay. I repeat this. Don't confuse. I to you, what is the relationship?
One way.
Teacher, right?
Yes.
You to me. I to you, student. I to you,
Many,
student.
many.
You to me.
The second is many. Many to one.
That is teacher. Okay. Ravi, Rani, friends. Now tell me. Ravi to Rani, what is the relationship? Friend. Rani to Ravi, friend. This is two-way. Understood? This is two-way. One way means from I to you. For example, Giri is father of Krishna. Giri to Krishna, what is the relationship? Son. Krishna to Giri, not son, right? It's a father. It's one way. It's one way. In this way, tomorrow, being a data engineer, your data is not like simple. How previously you have seen the structure. In this way, two-way connections, one-way connections will be there. Such kind of connections are simply called as a graph. For that graph databases industry is using. Got it? For usage point of view, that columnar storages will be helpful. To maintain the different schemas, document storages will be helpful. To maintain all my applications, because one organization is using hundreds of applications. Only my small organization is using 2 or 3 applications, but biggest of organization is using hundreds or even thousands of applications. For each application, how many keys? Got it? All these keys will be maintained at key value stores. Understood the point, sir? But their commercial data will always be into their enterprise data will always structured, right? And customer data might not be structured, but enterprise, the what you call business data. Business data is always structured, right? For that, already they are using RDBMS. Understand? All these are our challenges. Now tell me, come to this picture. Come to this picture. You have different sources. Oh, sorry. Let me keep the boxes. I'm giving a different color this for on the top boxes. 1, 2, 3, 4. Okay. Let me use left side OLTP systems. And let's go with some. It's all the things like that. Okay. I'm keeping your Azure data engineer in the middle. I'm keeping Azure data engineer products in the middle. See here, these are the things OLTP RDBMS databases. This is Oracle. For other application, DB2. For other different application, SQL Server. Okay. And on top, these are also OLTP systems, but this is MongoDB, which is document database. Got it. This is Cassandra, which is columnar storage database. And this is what I call graph database, which is Neo4j. Neo4j, which is graph database. This is key value database, maybe Azure Key Vault or something, which is key value database. In the bottom, there are streaming sources for you. IoT enabled sensors. That is one input for you. And next, these are the logs, the 2 web logs. You want to understand the customer behavior, customer navigational patterns. These streams are important. Got it. Now you are a data engineer. First, initially, your target is data ingestion. Traditional ETL developer is working with generally with the flat files or with relational database management systems. But today the data engineer, that means a little extension to the ETL. Basically ETL, what you are performing is ETL in the style of ELT or ETL, whatever it may be, ETL only. But on top of that ETL roles, you are going to perform additional roles and you are going to acquire additional skill sets. What other things you are going to work here? What other things you are going to work here? You should be able to connect with RDBMS sources, NoSQL, that two different types of NoSQL database sources, the two different streams and everything. Finally, extracting and dumping into your data lake and then do process. Final processed data you are keeping into Synapse. Again, where you are keeping your processed data, that is different. Sir. To whom you are going to make available of this processed data, that is important. For example, so for this question, I am going to give small clarity. Want to provision processed data to BIT. BIT means visualization team. Let's say visual. Within the BI, different teams will be there. That's why I'm talking about visualization team. Then dump into, that is processed data, I will dump into Synapse. Suppose their visualization system is Tableau or Power BI. The Power BI developers will be connecting with Synapse and they are generating their reports. Got it. What are the data I have processed? The processed results I will keep into the Synapse. Now, next thing, I want to provision processed data to data scientists or machine learning engineers or AI engineers. Then processed data I will keep into data lake. Understand? Even though data is structured, I will keep into data lake. From that data lake, machine learning engineers, they will build their models by taking that data. And next one, want to provision results. Existed online applications. That will be with big volumes. What are the data I have processed? This processed data should be taken by online applications. I don't want to give to BI team or data science team. Directly applications should take it. In this case, I will dump into a NoSQL database, which is Cosmos DB. Why Cosmos DB means the result of process one, the structure is different. The result of process two, structure is different. Got it. Or else if there is any specific reason, my target online application is using only Oracle database, I will dump into Oracle. First, as an initial shot, I will keep into Cosmos DB. From that, applications, they will take from Cosmos and they will dump into their Oracle. Other different application will take from Cosmos and dump into its own database. Understood all of you? In this way, different. Depends on the to whom I am provisioning, that is important for me. Okay, this is the general working style. I hope all of you understood a difference between regular ETL and this data engineering. Same responsibilities for on-premise data engineer also. But on-premise data engineer challenges, because he needs to work with physical clusters. Understand? So separate admin team, network team, a lot other team. Additionally, organizations have to maintain. In case of Azure also you require them, but very less team is enough. So this is what our Saturday session, the Saturday session by extension is today's session. On Saturday, we discussed about what are the different products in Azure Data Engineering and what each product is doing. Today, the data engineer responsibilities and required skills for him. This is what simply the full stack of a data engineer. But immediately you cannot become full stack. First, step by step. Part 1, ADF engineer. Of course, designated as data engineer. First initially, ADF. Next level, migrate to next levels. But already I told you, you need not to invest for second part of the course. I provide you the recordings of those things. Okay. So who wants this today's recording session and so yesterday's recording session? Please share your numbers into the chat, sir. Please share your numbers into the chat. Sir, here there is a question by Mr. Anil. Can we store Azure processed data into AWS? You can store. At the same time, some of the existed input might be at the AWS S3 bucket only. At the time, you have to make AWS S3 bucket as input source. Sir, Saturday session already I shared you into a chat. So all of you share it. If anybody missed it, I will share Saturday session and today's session by afternoon. Anyone pending?
No.
Okay. So tomorrow also the class will be there. So I did not share with Google Drive. I did not share with Google Drive. Just straight away I have given a Zoom link, a Zoom recorded link. Come on, sir, please make it fast. I'm going to close the session. Again, firstly, I will share both the sessions, today's session and Saturday session. Tomorrow also same link. Tomorrow actual ADF, we are entering into actual ADF, sir. So what are the concepts of ADF, how it works, we'll see from there. We start learning from basics onwards. The last two sessions, today and Saturday session, is about high level overview of data engineering. Tomorrow we are going to enter into our actual subject, which is ADF. Okay. Yeah. All of you, thank you very much for attending. Tomorrow, same link. Thank you.
Thanks,
Thank you.
everyone.
All right, good. Okay, sir, let's meet. Hmm? So please give me your email IDs on the paper. I will share you that recording for class. Hmm? Online team, for online team, I will share in the, at least give me your WhatsApp numbers and also your email IDs. I will share to that. Huh?